Yeah, the final one, it's sort of interesting. Where's Alison? I think, in a sense, Alison, SFI is a childish institution.
Exactly,
right?
that's right. That's what I've always said.
No, but it really is, because, I mean, the diversity of this room, it feels highly non-annealed, right? The one thing I did want to say, so institutionally, it's sort of interesting, I don't know how it applies to other people's, is at least I spend a lot of my time thinking about how to create an institute or foster an institute that is somewhat anomalous in the space of institutions. And it's interesting that the best known search algorithm for researchers is what's called the scientific method. It doesn't really exist. But if there's a candidate hypothesis for scientific method, it's Karl Popper in Conjectures and Refutations. And for those who probably know him, the Austrian philosopher of science, the idea was you have very, very outlandish conjectures, and then you ruthlessly refute them. But what's so strange is it's exactly how science is not practiced. The worst science that we've seen in the last decade, by Popper's standards, is the discovery of gravitational waves, right? I mean, it's just appalling. And there's a 100-year-old theory, millions of dollars, essentially poured at essentially corroborating an existing theory. And of course, that's exactly the opposite of what we should be doing. So it's a terrible science. And there's a Nobel Prize awarded for it. And it's a disgraceful thing. But it's an interesting question. It's sort of not how we really do science. So this sort of notion of exploration by negative reinforcement is really not what happens. I mean, large institutions are essentially rewarded for corroboration. Okay, so I just wanted to make that point, let's rant about it. This panel's a particularly diverse microcosm of the issue of search, because we've got Graham, who started off doing search as would be familiar to this community, and then, you know, went down the dark path, and now looks for investment searching opportunities. And so the question is, to what extent is Graham just randomly picking, it seems to me, within an organization that's such an extraordinary security blanket that would never be revealed to the rest of the world? Or is he actually good at his job? And I don't know, you have to tell me. But he's also on the board of the Scientific Institute. For that reason, I have to say he's good at his job. But he's remunerated by Google, so I don't really care if he's good at his job. So that's Graham. Pete Warden's the most outlandish in some respects, and traditional, comes from a military background, ran NASA Ames around the corner, and now runs the Breakthrough Prize and is a part of our interplanetary project in some respects. And we'll be talking about searching for life in outer space. And just now told me he's even interested in looking for life that might have left, extraterrestrial life that might have left an imprint in terrestrial genomes. So he's really out there and in interesting ways. And Jeremy Lewis, who's here, perhaps the most frightening, looking for proliferated nuclear weapons. And most recently, they did something very, I haven't read the book, but I thought it was really interesting, has recently written a novel, which is a sort of counterfactual, or I hope counterfactual exploration of what what would happen if there was a serious nuclear encounter or showdown with North Korea. And so this is an interesting exploration of that possible world, which is a very gloomy one. So with that said, I don't know, what's the order? Does it matter?
I don't think it matters.
Okay, Graham, you're nearest. So do you want to go first?
What am I supposed to do?
I don't know.
You have 5 to 10 minutes just to sort of introduce yourself a little bit.
Yeah. What's your search strategy?
Well, after that flattering introduction, I don't really know where to go. And I didn't really expect to even have to say remarks. I thought you were just going to ask me questions. So
Well, make a few and then I'll
make
ask
a
you
few
questions.
remarks. So we're in the Google Ventures building, and so this is the place where we do the business of venture. I think that there are a bunch of really interesting questions about the way search works in the venture capital industry. I think that you were sort of asking the question of whether this is all random, and I think unfortunately there's some evidence that it's even worse than random in a lot of cases. So the average, if you were to randomly pick companies across a space of time, across a duration of time, if you just randomly pick a bunch of companies and then put them in a portfolio, the mean return on that portfolio would be about 1.5x. So you'd basically make half again as much money. However, the median venture capital firm loses money. So more than half of all venture firms are doing significantly worse than making 50%. They're actually losing money, and you have to get up until roughly the sort of top quartile of VC firms before you're even doing as well as just randomly picking. And so you might ask, how could that possibly be the case? I mean, these people aren't dumb. How could they be doing worse than chance? And so I think that has to do a lot with the underlying mechanism of search in the entrepreneurial ecosystem. So you have, as we were talking about in the dating case, you have a two-sided sort of search market, because you have venture capitalists who are searching for investments, but you also have entrepreneurs who are searching for investors. And so the way that you can imagine, I mean, this is hypothetical, we don't really have any concrete evidence, but you can imagine the way an entrepreneur might work is that they would think about the best possible VC they could get, and they'd start with that person at the top of their list, and then they'd sort of move down until they got funding. And meanwhile, a VC is seeing investments come across their desk, and that's a little bit like the secretary problem that we talked about earlier, because you're seeing investments come to you, and you're trying to figure out, how can I say yes to the best possible investments that are coming to me? So you have this two-way matching problem. And the problem for an investor who's sort of lower tier in that mix is that as they're searching for their investments, they're mostly getting entrepreneurs who have already failed at getting investments higher up on the list, because the entrepreneurs have a mental ranking. Now, none of those rankings have to be perfect. Entrepreneurs don't exactly know who the best VC is, and it will vary depending on who the entrepreneur is. VCs certainly don't know with certainty who the best entrepreneurs are, but because of the way that matching process works, the venture capitalists, each venture capitalist is searching in a fairly narrow subset of the overall space. And so the ones who are lower on the list are searching in a very adverse subset of all entrepreneurs. And so they tend to get bad entrepreneurs, and then they tend to get bad returns. So I don't know, that's sort of how I think of search in the venture capital space. I think there's a couple of other nuances to it. I think the most aspirational version is that venture capitalists and entrepreneurs are searching in the space of innovation. We're all searching for particular companies that are going to exceed in any metric, usually sort of capital returns. And the question is whether we can actually find those subspaces, who's leading, who's following. Those are all really interesting questions. The last bit of the search problem, which Fred and I were talking about in the morning, is once companies have moved in one direction, if they realize that that direction is not all that great, how do they search within their own space of possibilities to figure out what their next thing is going to be? So we all have heard the stories of very famous successful companies that started off doing one thing that was a terrible idea and then ended up being really successful with their second or third or fourth idea. Some of those companies are in our own portfolio, and they're set to have potentially good exits, but they started off doing something completely different. And so how do we think about the search process within entrepreneurship?
Can I ask you two questions?
Sure.
One is, any thoughts on preferential attachment in your industry? Second, if I do attach to a great VC, is there a network there that will help me boost my probabilities of returns or success A and then return second?
Right. Both really good questions. I think it is absolutely preferential attachment on the part of entrepreneurs. If I'm a first-time entrepreneur, I have a mental list. Sequoia, Greylock, Excel, Benchmark. If I think I have any chance of getting funding from those investors, I'm going to start there, and I'm just going to move down that list until someone finally says yes. You can imagine that if I'm an entrepreneur in a different part of the world, I don't have access, I can't make it out to Sand Hill, or I don't have contacts at those firms, so I can't get a meeting, then I might start with a different set. But I'm preferentially attaching to the best that I can, and that leads to this matching. The network question is really interesting. There's a little bit of research on that. I think the most compelling research on that, it'll just take me a minute to explain. So if you imagine a network of venture capitalist investors where each node is a firm, and then you have edges between them based on when they invest together. So Kleiner Perkins and Sequoia both put money into company X, so they add weight to that edge. So if you make that graph, then it turns out, there's all kinds of things you can do in terms of network analysis to try and look at who's most central in that graph and who's least central. But one of the most interesting findings is that the firms that are most central in that graph, when they invest in companies, those companies outperform, even if those firms are the only investor. So those firms have previously co-invested with lots of people, but now they're the sole investor in this company X. Company X will tend to outperform if that VC is central in that network. And the best hypothesis, I think, for why that's the case is that those VCs are able to route resources to their companies, and so they have the centrality of the network lets them route interesting things to those companies to help them succeed. Sure. Is it okay for me to take questions?
Yeah.
Okay. Sure. Yeah.
I mean, first of all, let me caveat this by saying I don't actually believe what I'm about to ask you, but just
Okay.
as a devil's advocate, isn't the data, the facts that you just suggested also consistent with saying, like, all VCs are starting with no information, they purchase options effectively, the average loss, I guess, is the average premium of the option, and then the ones who happened to win, right, get that skewed distribution. And then, of course, there's a signaling issue. Like, once you won, then you might get cheaper options in the future because of that you won. So it's not like those guys are actually getting the information that's appropriate to find the deals, but just like ended up winning that lottery ticket. And that data that you mentioned is consistent with that. I mean, the empirical facts are consistent.
So, well, I'll make two comments. So as I described so far, you're absolutely correct. It's consistent with that. There's a further refinement of that study where they look only at early investments by venture capitalists before they've been able to build a reputation, but where they nonetheless have better network centrality, and that continues to support the hypothesis. But you're absolutely right. There's sort of, at least the way I think about it, there's three potential mechanisms that could account for VC success. One is what you just said. You've built, everyone's guessing randomly. There's no skill, but there's a compounding factor to luck, because if I happen to get lucky and get into Google, Facebook, Uber, whatever, other entrepreneurs are going to think I'm good, and they're going to preferentially attach to me first. So that's one hypothesis. And in that hypothesis, there's no skill on the part of VCs, but there is persistence of performance. And we do empirically observe a lot of persistence of performance in VC. Hypothesis two is that VCs are good at picking companies. They don't do anything else. But they can recognize innovation when they see it. And so as companies are coming to them, or as they are looking at other companies out there in the entrepreneurial ecosystem, they're able to do a better job of saying yes to the good ones and no to the bad ones. And then the third hypothesis is that neither of those other two things are true. VCs can't pick at all. Nobody can predict innovation, but VCs are good at supporting companies once they've made an investment. So if you are a Sequoia or a Greylock or an Excel, you're just really, really good. You've seen 100, 200, 300 companies in your portfolio already. You know what's going to make them succeed and what's not as a general rule. And so that is the difference. There are academic papers that support all three of those hypotheses. I think it's kind of intuitive that probably all three of them are true to some extent. It's a really interesting question and an unanswered question. You know, do any one of those three factors dominate? Like, is it really just mostly luck? Is it mostly the ability to pick winners? Is it mostly the ability to support companies after the fact? I think of that as like the main unanswered question in our industry.
Great. So I'm Jeffrey Lewis. I'm at the Middlebury Institute of International Studies at Monterey. Yeah, the slides are not mission critical if it doesn't work. It's just sometimes it's a little easier with pictures. So I study the spread of nuclear weapons, and I was thinking as we were like listening to this stuff about the dating apps and Tinder, right? The whole idea of Tinder is you're going to use search, I guess, so that spark catches fire. In nuclear weapons, I want the exact opposite of that. I don't want that at all. So just to briefly explain what we do and how I imagine that relates to this question of search, you know, we're in the business of trying to understand what kind of nuclear weapons other countries are building. And like, that's tough, right? And so what we really do, our work is kind of, we replicate the functions of an intelligence community, but we do it on an open basis using publicly available information. So, you know, the big inspiration for me was the nightmare before the invasion of Iraq, right? Where, you know, you had these intelligence claims that were made and civil society didn't really have the ability to say anything meaningful. And so people just had to sit there and say like, well, I mean, you know, the man with the kind of boring tie said it's true, so it must be true. And our goal is to be able to publicly hold those claims to account. There are some really weird things, though, about the way we deal with search, and I don't know if people know who this guy is, but that's Gary Powers, right? So, I mean, the first issue for us when it comes to search, like looking for nuclear weapons, is they're supposed to be secret, right? Like, the people that we're looking at don't want us to know, and so when the US government initially tried to do exhaustive searching, it was, you know, you put Gary Powers in a plane and you fly him over the Soviet Union, and they shoot at him. And I am not getting in a plane, and I definitely don't want to get shot at. And so today it's a little bit different for us. We rely on commercial satellite images, and I have to say the joy of social media, because you'd be amazed at what human beings, particularly like 19-year-old men, put online. It's really incredible. Like I don't want to get too far off topic, but we spent a lot of time looking at like the Russian site involved in nuclear testing. And so I basically get a lot of pictures of naked Russian men in the Arctic. There's not much to do up there. Now, I have to say that thing about it being secret, it's not exactly correct. What's more correct is countries want us to know some things, and our job is to figure out whether those some things are true or false, and then to find out the things they didn't want us to know. So for example, the reason that poor Gary Powers is flying over the Soviet Union is the Soviets were representing that they had a large number of bombers. At parades, they would fly the same bombers over and over and over again to create the depiction that there was a large number. And so the task of U-2 overflights was to determine that no, in fact, there was no bomber gap, right? So that's the first thing for us that's like really weird. There's a second thing, and this picture goes to it. I know it's not all that great of a looking picture. You're probably wondering what the heck is it, right? Is the other problem for us when we are searching for foreign nuclear weapons programs is what I would call indirectness. A nuclear weapon is not a large thing, right? I mean, it's, like this. You're not going to be able to see that in a satellite image. Even the best commercial satellite images, you're talking 30 centimeters resolution. Like, you're just not going to be able to resolve a nuclear weapon. And so what we actually end up looking for are indirect signs of nuclear weapons. So that's everything from the facilities that produce the material that goes in a nuclear weapon, like a nuclear reactor to produce plutonium, all the way to the facilities that house the weapon systems like the missiles that might deliver that nuclear warhead from, in this case, the Soviet Union, or from North Korea in my book, all the way to, here, beautiful Mountain View. And so this actually, I mentioned the bomber gap. There's a second concern in the 1960s of a missile gap. That gets resolved with satellite photography, and this is one of the images that resolves it. That's a nuclear weapon, kind of, right? What that really is that's a Soviet missile silo, right? So you're looking down, that's a hole in the ground, and it's got a concrete block over the top. And from the outside, if you're searching, you have to look at that thing and go, oh, I know what that thing is. That's a missile silo, right? And that's not immediately apparent, right? And I presume everyone knows about the Cuban Missile Crisis. The Cuban Missile Crisis is one of the strangest crises in human history, because the United States initiates this crisis on the basis of overhead images, all right? There are no pictures of missiles in Cuba, right? There are pictures of what the intelligence community correctly assessed to be missile sites. There are some pictures of launchers, not with missiles on them, and then there are pictures of tents that had missiles in them, right? But there are no pictures of missiles. And so when the intelligence community had to brief that to President Kennedy, he was sort of like, well, I mean, are you sure? Because I don't see any missiles. We're going to go this close to ending human civilization here. You're right, right? And they said yes, and he believed them. And famously, Robert F. Kennedy, when he's asked about it, said like, well, I mean, I guess I believe you, but it looks like they're building a basement to me, right? And so I mean, that's a weird thing to go through a potentially civilization-ending crisis when you can't actually see what you're looking at. You're kind of dealing with stuff like this. And the reason I point that out is because the reason they were so confident, which is like the third weird thing about what I do, is they weren't really, I mean, yes, they knew what they thought missile sites should look like, but what was most important is the things that they saw that they thought were missile sites didn't look like anything else in Cuba, right? So what a real photo interpreter does, and what we train our staff to do, are to look for anomalies. And this is tough for us because we would love to partner with tech companies to do a lot of machine learning. And when I talk to tech companies, they're like, okay, well, tell me what you're looking for. And it's like, that's not what I do. Like, I'm looking for things that don't fit, right? So often I'm looking at an image and I see a whole bunch of things, and I'm looking for the things that are anomalous. I mean, it is true that there are some cases. We spend a lot of time talking about signatures and thinking about what signatures look like. So, for example, something like this, to me, has a lot of signatures. Like you've got, oh, yeah, I'll skip that. You've got like, fencing around it, nice paved road. But what's really weird is it's anomalous, right? Like, that's incredible fencing for a crappy farm in Soviet Russia. That's a wonderfully paved route for the Soviet Union. So it turns out that becomes a very hard thing for search because we can describe the signatures we're looking for, but 9 times out of 10 what we end up finding are things that are odd. I will skip that because I know we're running a little behind. I will just give you 2 practical examples of the kind of stuff we do. This is a Saudi facility for building ballistic missiles that was probably provided by the Chinese. We found this, and it was a surprise to us because it was actually located at a facility we were looking at for some other reason. And what popped out, again, is it was weird. And it doesn't look like anything else. And the more we looked at it, we said, oh, well, that's a missile production facility. And I mean, I show you this because to me it obviously is. Right? Because it has these high bay buildings that are very tall because you want to stand the motor casing up on end and pour the fuel, what will become the solid fuel, into it. And those big buildings are surrounded by earthen berms because sometimes they have a tendency to explode. One of these places went up in Iran, and the head of Iran's solid-fueled missile program was killed. They never found his head. And there are lightning rods all around. Right? Because people, if they're going to die, they'd like to be buried with their head. And down in the far corner, there's a weird-looking building that's a dead ringer for a Chinese engine test stand to fire the missiles, right? So I mean, this is a perfect example of the kind of thing we're doing. Like, we look at this and we say, oh, China is helping Saudi Arabia build ballistic missiles. I don't know how to automate that yet. Right? I don't know how to teach a machine to do that. I would love to. So this room in particular, we're very interested. One other thing I'll just do quickly, which kind of goes to the fun of social media, and then I promise I'm done. This is Tehran. A couple of years ago, there was a claim that the Iranians had built an underground facility for enriching uranium. The leak of this information was perfectly timed for the worst diplomatic effect it could have. And the description from the dissident group was pretty vague. It's in this building. We were able to find the building. It's got a lot of security, they said, that was pretty unusual, right, which is that anomaly that we would really like. And so we wanted to figure out, is this story true? Is there really this underground facility? And that's just my favorite social media story. Does anybody know OpenStreetMap? Do you participate in it, any of you? You lovely weirdos. So it turns out this is a trace used to build OpenStreetMap. Oh, can I play it? Yeah. No. Oh, well, okay, that's not what I was hoping for, but I don't know why it's rendering like that. Ah, there it is, right? So that's the street map. We found a guy who'd stayed at a hotel who visited the site and posted his thing. And it turns out we tracked him down in Germany. He didn't want to tell us all of his personal data, but do you know what I do? I look for nuclear weapons. It turns out I found his hobbies, his spouse, his actual place of employment. He's a real dude. Not that we would burn him. He'd actually visited the site because actually he works for a company that makes serialization machines. That's the machine that puts the number in your passport, right, and makes it unique. And so this is a facility for making passports, and we're able to confirm that then, through the foreign government contact, all because this crazy person didn't put it online, right? So I mean, the the big takeaway from that, right, is we still have, I think, all the same fundamental problems when poor Gary Powers was flying over the Soviet Union. We just struggle in the same ways with search, but we do live in this kind of funny, bizarre environment that they didn't have in the 1950s. Where folks like Planet Labs, who are friends of Pete's, take pictures and give them to us, and then weirdos post things online. So,
well, I used to be a space guy, and now I'm a search for aliens. So I guess that's what space people do. The breakthrough prize foundation I run, we do two things. We give out the world's largest prizes in science, about roughly 3 times the size of some Swedish prize I'm not supposed to mention. And, but the other half of what we do with a bunch of initiatives, and so I'll talk about these. I guess I just hit the, but I want to specifically talk about the search for life, and one of the key places we're looking for. And this is kind of an interesting search because we have no idea if there's any life elsewhere. In fact, a lot of people think there isn't. But the first place to search is the next nearest star system, and for astronomers, this is like really close. It's only 300,000 times further away than the sun. It's the Alpha Centauri system. It's 4.3 light years away. There's the interesting system. There are 3 stars in it, and when we started, nobody knew anything other than there were 3 stars. The 2 of them are kind of the size of the sun. One's a little bigger, one's a little smaller. And somebody pointed out this was a bad chart because it had the same sunspots, the star spots the sun did. The third one is a small star. It's called a red dwarf star, Proxima Centauri. It's about 10% the mass of the sun, and maybe a 10,000th is bright. It's a red dwarf star, which most of the stars in the galaxy are. And I'll talk a little more about those in a minute. The initiatives were started in 2015, privately funded. The fellow on the right, on my right, is Yuri Milner. He's a physicist, Russian, on his way to become a U.S. citizen. I need to make sure everybody knows that. That is a major investor. He runs DST Global. You probably recognize the scientist there in the picture. Until his death last year, Stephen was our senior science advisor. But the initiatives were announced at the Royal Society in London, and we had 3 objectives. And these are simple questions. Is there life anywhere? Anywhere else? Is there intelligent life elsewhere? And when I give this talk, I always have to note that the closer you are to Washington, the more doubtful you have, or maybe London or other places. And the one that I always found most fascinating is part of the questions is, can we travel between the stars? Now, talk about why that may be really important for our search. Probably the major initiative that we're putting the most effort in is traveling between the stars. In 2016, we announced Breakthrough Starshot, which was an attempt to figure out if we can develop in the next few decades technology that would enable us to send a probe to Alpha Centauri and return some data. This was announced at the New World Trade Center on April 12th, 2016, again with Hawking and Milner and a usual cast of suspects. But the basic idea is really to look, is there life in the Alpha Centauri system? We want to take science data, if there are planets there, and return that data back to Earth. We'd like to launch within 30 years and at an affordable cost, which we said was roughly, one Large Hadron Collider, or 10 billion euros or dollars, take your pick. And to do this, we have to go really fast. And fast is 20% the speed of light, which is really only about, 1,000 times faster than we go today. And so we looked at how to do this, and we were going to use a huge laser to push a light sail attached to a star chip. And this is a prototype of the little chip in the corner of it. That's the satellite we would send interstellar distances. And we're actually closer than this we thought. This was launched a few months ago, about 100 of these. This is actually built by students at Stanford. And so the technology isn't that far away to put everything you can in a satellite in a small spacecraft. Of course, the key question is there any place that we need to search, any place to go in the nearest star system? This is called Breakthrough Watch. And we made our announcement in, as I said, May 12th, 2016, without knowing of anything in the Alpha Centauri system, and just proving sometimes it's better to be lucky than good. A few months later, the European Southern Observatory announces that there is a planet orbiting Proxima Centauri that's actually Earth-size, and it's in what we call a habitable zone, meaning there could be liquid water on the surface. They were nice enough to invite me to the announcement. Of course, they had an ulterior motive because we were nice enough to give them $5 million. Of course, they have a picture of the planet, so I guess we don't need to go there. By the way, artists that do astronomy are the world's best. I mean, you know, I don't think we need to go anywhere. We can just hire these artists. But what we're doing, in fact, as we speak, this is the very large telescope in Chile, imaginatively named. And there's 4 8-meter telescopes, and we have an instrument that actually, I think tonight is its first night taking data on that one, which is going to try to directly image this planet. And then in about 6 or 8 years, this telescope will be completed. This is called the Extremely Large Telescope. By the way, and this is not kidding, that initially this was going to be called the Overwhelmingly Large Telescope, but they had a budget cut. And so it was supposed to be 60 or 70 meters, and now it's only 39 meters. But this telescope will be able to determine, we can actually observe the physics of the atmosphere on these planets if we find them. So it's that may be the first evidence of life. But I think probably the most interesting thing, which you heard about earlier, was another question which is more biological, and this is where we're kind of switching our search. First of all, we don't know what life is. You know, we assume that it's biologic or it's carbon-based, but maybe not. That one of the key questions that's always been a bit on the fringe of science is what's called panspermia. I think the first question we had was, a lot of people didn't like the name, so they proposed panovaria and other things. But this is the question of migrating life in the universe. And the fundamental question is, did life come to Earth from elsewhere? Is there information in these genomes that suggest its source, maybe even an intelligent source? And maybe the most interesting thing is can we do this in the future? And again, the question of life from space. Now, this was considered to be, life may transfer between the planets in our solar system, but what about interstellar? You know, can you come from the nearest star system, which is hundreds of thousands of times further away than our solar system? And we would have said no until recently. And we had our first interstellar visitor about a year ago. This is the asteroid Oumuamua, which clearly came from interstellar space. We don't know a lot about it, other than it was kind of an elongated object. And I will say that this now has become rather interesting because there are people, including this guy, who's the chairman of our advisory committee, by the way, Avi Loeb at Harvard, who said this was actually one of these kind of star probes. So the idea that you could travel between the stars and deliberately do things got to be very interesting. Probably the most interesting concept was, and this was proposed by a number, but Francis Crick and his colleague Leslie Orgel in 1973 suggested directed panspermia, that stuff like this could carry life, that again booted up life on Earth. And of course, there's been movies about this. The Prometheus, I guess, was this one. But probably the most interesting suggestion is that we can do this. This is George Church, who's trying to reboot things like woolly mammoths. And he suggested that using these kind of probes is the ideal way, if we are really alone in the universe, that we could potentially plant life elsewhere. I love the cartooning. This is one of his charts. You know, why there aren't any dinosaurs. But if all goes well, you know, in a few decades we might have our first image of maybe a life-bearing planet nearby, and maybe in a millennia or two we'll be able to boot up life elsewhere. But this is probably, I think, one of the more interesting searches. We do have a major search for extraterrestrial intelligence. We have been funding efforts on using some of the world's largest radio and optical telescopes. We just have our first major paper. No aliens yet, but you don't really know what to look for, you know, and that's one of the big questions of, you know, information theory. In fact, if you look at the way our communications are going, spread spectrum and so on, we maybe just want to look for noise. So our problem's even harder. I mean, at least we know what a nuclear weapon, the physics, but we haven't the slightest idea what these aliens would do. And anyhow, thanks.
So I'm going to ask one question, then open it up because it's very broad, very broad. But
Keep it on.
oh yeah, and it has to do with data, right? So
Is this on? Okay.
And so, in some sense, the first two presentations are benefiting. I'm imagining you benefit from the kind of data you sit on here, and Jeffrey, also you're getting a lot of data, social media data. Pete's slightly more problematic. It's something. But I'm just curious, in all of these instances, to what extent you ended on a slightly gloomy note, Graham? It's like, well, maybe we are just guessing. So,
Should I pass this?
well, yeah, so you can
No, I've
all
got-
answer.
I've got one.
Yeah,
We all have mics. Okay.
yeah, but it's really this question about are these fields where we could see the same kind of very significant increases in success by virtue of having huge data sets and computation power, or is there something about these search problems that's sort of some other rate limiting factor that you haven't yet discussed that have kept them very squarely in the sort of first half of the 20th century? They're not benefiting from the Moore's law-like effects that so many other things that we discuss are. So what's rate limiting in progress here if you have the data and the computational power?
Well, should I? For entrepreneurship, I think one of the big rate limiting factors, there's a couple. One is just the time between when a company starts and when you observe the outcome of that company. It's median 5 years. So, the venture business has been around for a while, but certainly not 10 generations of interesting companies. I mean, maybe there's a tiny bit of venture business before then, but and particularly institutionalized venture, where we're seeing thousands of firms and hundreds of thousands of companies, that's really only a few generations of companies, and so there's really not that much data. And then the other issue that we have is that there's a huge amount of randomness in any company formation. So all kinds of things could happen that could cause a company to die. One of the things that we struggle with a lot is this idea that, when we observe a company that's failed, it doesn't give us any more information about whether that was a company that came really close, like great founders, but they just barely missed it, versus a bunch of nincompoops who had no idea what they were doing and got money from a Z-tier venture capitalist and then just blew it all in parties and failed. Like, we can't distinguish those two outcomes because everything is censored at zero for us. And so the sort of noise of the super high, very fortunate outcomes, which are driven a lot by luck but also by skill, and then the fact that we don't observe how bad a company really was, that makes it really hard for us to do any kind of estimation. So.
Dave, there's something else, I don't know if this is relevant, Graham, too, it's just the structure. So, and correct me if I'm wrong, but it seems like the venture business is much bigger in the United States than other countries. So it's an interesting question as to why it's not, maybe China's rising, but certainly Europe and other parts of the world, and it's an interesting question as to why it's not bigger in other parts of the world. Data is now accessible, computing are accessible, but there's an infrastructure probably related to Stanford being here, sort of culture of winning and losing money, money flowing, laws, intellectual property, all these other things.
Yeah, that's a great point. I mean, you see that venture capital, I'm pretty sure I have this right, is declining in Europe, partially due to regulations, partially due to other reasons. You see that Silicon Valley, I don't know if this is true in specifically the last year, but Silicon Valley has continued to get a greater share of venture capital dollars than other major areas that have venture investing. So there's really something about the local network of investors, of prior companies, founders who are at successful companies, and then there's a diaspora, and then they start new companies. That all concentrates the effects in Silicon Valley in a way that's, I think, really interesting and not well understood.
I think that's true of Europe, but not true of Asia. Asia continues to grow. I think it's almost the same size in terms of dollar.
China is, yeah.
Yeah, China dominates because of its size, but if you look at the rate of growth, the rest of Asia is growing actually faster than China, even though dollars are lower.
The dollars are very small outside of China, but for sure China is really big. And I think China is poorly understood by most U.S. investors because it's a very different market. Sequoia, I think, announced publicly that they're shifting their base of operations to China. So there are leading VCs here who are making that shift.
I feel like I should stop looking for nuclear weapons and start looking for inefficiently allocated VC capital.
Sure.
So I actually think that what I do will experience rapid change because, there's a particular site in North Korea that's believed to be it's a site for enriching uranium for nuclear weapons that the North Koreans have never declared. And the U.S. intelligence community hypothesized its existence based on a shipment of aluminum tubes in 2002. They didn't identify the building that they later decided was the site until 2007, and that's just when they noticed that a thing was being built. And they didn't determine that they thought that this was the place where those tubes were headed and was likely an enrichment facility until 2010. And there are kind of two problems that slowed them down that I don't think we're going to have forever. I mean, one problem is just getting enough pictures. I made the joke, but we actually worked closely with a company called Planet Labs in San Francisco that Pete mentored all three of the founders.
Yeah.
Yeah.
They almost got me put in jail.
Well, I got to tell you, so many damn beautiful pictures, it's worth it. I mean, and they take a 3-meter image of the Earth pretty much every day. But then there are also a bunch of other small satellite companies that are offering higher resolution images. And so you just get a lot more pictures, right? And so then the second problem, which I think the intelligence community ran into, and we certainly run into, but which could be solved if we could ever teach machines to look the way we look, is then processing this data. And we're at the point now where we have more images than we can look at. And so that problem I think will eventually get solved. And the facility, to me, right, to my trained eye, should have been picked up immediately. You take one look at the thing and you're like, oh, well, I don't know what that is, but that doesn't belong here. Right? And if we could get a machine to do that, there are enough pictures being taken on frequent basis that there's no reason you'd wait for 5 years to notice it was getting built, let alone another 3 years to make a guess as to what it was.
Jeff, do you get government funding? It seems as if you should. It's an independent check of the intelligence agencies,
We have a very nice relationship with some aspects of the U.S. government in the sense that they're very interested in what we have to say, and they listen very attentively, and then they thank us profusely, and then they don't say anything, and no money arrives. I'm not too bothered by that. I mean, we do have to stay independent and separate. It's not that we don't take government money. We would do consulting contracts and things. But I think to a first approximation, our relationship is one of they consume our information like they do all of the other information that's available to them, and that's kind of the end of it.
Jeffrey, how do you think about things in terms of probabilities?
Yeah.
It's one thing to say
Mhm.
it is or it's not.
Yep.
But I imagine you have everything
Yep.
from its low probability to high probability.
Yep.
And how do you think about expressing it that
Mhm.
way, and maybe the policy implications? You mentioned, the
Yep.
Cuban Missile Crisis is really
It's
interesting.
so
They
important.
went as if it was a 1-0.
Mhm.
If it was even a,
I know.
oh, yeah.
Yeah, no, you're 100% right. So the first thing is the intelligence community has this problem. And since we train a lot of students to go into the intelligence community, we just replicate broadly what they do. And they have a kind of, it's a numerical scale, but it's really qualitative in terms of both the probability of something being what it is, and then they treat separately their confidence, which I've always thought was really weird because I don't know how you could have low confidence that this was a high probability thing. But we try to mimic that because we have this educational mission. I would add to that, and I really struggle getting people to think about it this way, Our confidence has to slide depending on what we're asking someone to do. You know, so if it's, you know, should the IAEA send an inspector to look at this site? Yes, I am confident enough in this judgment that you should do that, right? Then if the question is, well, if they don't let them in, should we bomb it? Well, I'm not that confident, right? You know, and that is a big problem we have, where we want to express an abstract level of confidence in what we know, which often is indirect, right? Signature based, like the North Korean facility I was talking about. What's weird about that is the housing. It is gorgeous high-rise housing in the middle of an area lived in by steel workers who don't normally live in gorgeous high-rise housing. Again, that's enough for the IAEA to go in. It's probably not worth starting a war over.
Questions?
Yeah, one question too.
Pete, did you want to?
Oh, did you want to comment on the data stuff?
Well, I think just very quickly is, we don't have the slightest idea what we're looking for.
Right.
And it, you know, what we've done in these things is, we don't even know what life is. And it's sort of like the person looking for his key under the lamppost, because that's the only thing we know what to do. We look for signals that look like things that we would do, and we look for biology that looks like biology we know. There is a data problem. We got time on some of the world's largest, mostly radio telescopes. We take over 2 petabytes a day, and you don't even know what you're looking for, but how do you search through all that? And just to search for radio signals that look like our radio signals is hard. You know, one of the things that, you know, I was struck with your comment earlier about young people, and especially, in fact, we might want to go even younger, but we're thinking on looking for signals in genomes, is rather than asking college professors to do it, is ask undergrads. And so I've been working with Arizona State to challenge their undergrads to look at all the published genomes, and do you see anything weird? And you know, I think that if you don't know what you're looking for, you're more likely to find it. And you know, again, you have no idea, so it really is a open-ended question. That more computing power, you know, using some level of machine learning would certainly help, but only if you know what you're looking for. And I think, and ultimately, it's people. It's if you have people that say there's something weird about this data set. This signal has some characteristic that just doesn't look normal.
Question to Jeff. I think the question about probability comes down to trust between what you provide and trust between you and your client, basically. Like, do your client trust the summary of probability that you provide, or do they want raw data? Similar to, I guess, going back to the debates of rule-based versus machine learning on this golf, say from Google search was against using machine learning because it's more like a black box. I don't know if that's true. I heard of that. Because you cannot dissect what is behind that probability or that model. I guess, how do you deal with that kind of trust? Oh, you give me like 0.7% that this is going to happen. I actually don't want that. I want to, you know, use my own judgment. I want to get the raw data.
Yeah, so, you know, we're not, this is a problem the US intelligence community has a lot, and so we don't exactly have it, although we train our students who are going to have to deal with it. Policymakers always want raw data, and you should never, ever, 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 ever let them see it. Because, you know, this is an act of interpretation when you're looking at a photograph. And actually, we have some very fancy software to look for digital alterations to photographs. And it is very difficult to quantify the anomalies that the software detects. It really, again, is an act of interpretation. And so, you know, we try to be very, in our published work, but then also I think in training students, we try to train them to be very clear about why they have reached an interpretive judgment. So for example, pointing out that the housing at this particular facility is very atypical for this area, and that everything you know about how housing is assigned in North Korea would just lead you to think this is very strange. And with satellite images, it's kind of okay to show people pictures, but there are actually other intelligence communities around the world that don't take this approach. So like the Russian system is very much just raw data. It's just reports. And we actually detect this a lot in our kind of track 2 conversations with Russian officials. They have in my experience, they have a very poor understanding of the proliferation situation around the world because they tend to get reports and are allowed to cherry pick. And so it becomes very easy for their judgments to get politicized. Because, I'm like, if I wanted to be a hack, I can really argue anything. I mean, I could find a defector who says something it comes to being very direct about why we reach certain judgments. But then the downside is it also makes us a little risk averse. I'd love to go public with every 90% confidence judgment I have. That means I'm going to look like an idiot 10% of the time, and that would be the end of my professional existence. So we do really try to stick to the most obvious and strong judgments we can, and I think the consequence of that is there are all kinds of interesting things we see around the world that we don't share for that reason.
So Jeffrey, what is going on in North Korea?
I mean, they're building nuclear weapons. Building lots of nuclear weapons and the missiles to deliver them. I mean, it's actually, I have to say, my career is very alienating because we have a political discourse in this country, and our political discourse always takes the same form, which is, and it doesn't matter, the president says one thing, and then the president's opponents say something else, and then we have an argument. And that conversation is often completely disconnected to okay, well, I saw a truck show up at the facility that builds the missiles, and it had a big canister on it. And the only thing that canister is used to carry missiles, and then it drove away. So we often have our own internal dialogue about what's happening in the world that feels really disconnected from the political debate. So yeah, they have continued to produce nuclear weapons and the missiles to deliver them, and they've continued to expand the facilities used to produce those. And so it's just very strange to me.
And the intelligence community knows that, I think?
Oh yeah, they know it, but I mean, they have a client, and then their client has a view, and I have a lot of friends who work in that administration, and so I mean, just privately, sort of, they don't tell me what they see, but I'll sometimes be like, did you see? And they're like, yeah, but and that's not going to be in the New York Times.
Well, that was scary.
I have a slightly off-topic question, but just for curiosity.
How could anything be off topic?
So many sci-fi stories will encounter less intelligent life, and our reactions ranges from one side of we need to cultivate them, help them develop, to the other side of the dark forest theory of we need to eliminate them in fear of making them devastating us. In reality, where will we have a sense of where we'll be in that spectrum?
That's a fascinating question. This gets to what's called the Fermi paradox, which Fermi really didn't state it this way, but it's that we're not a terribly old or young planet. If life is endemic, and there's no reason to believe it isn't, or that it is, then we would expect there would be civilizations that were much older. So why aren't they here? Now, a lot of my former employees at Ames thought they were. In fact, I thought some of them were aliens. But I guess my conclusion is that we've only been a technological civilization for arguably a few thousand years, probably a lot less. That there's there's really no reason to believe that another intelligent species would be technological at all. And there's also no way to tell where technology goes. You know, I mean, one of probably the prevailing view in the scientific community is we're about to download ourselves into machines, and so that if these other civilizations existed, they're probably gone somewhere else and are not really interested in interacting with us. My own personal view, and this is all based on, you know, no data, or data at one point, here is that intelligent life is very rare. That if you look through the chain that brought even complicated life, eukaryotic life on Earth, which has had a sophisticated enough genome to store enough information, enough energy, was a chance event that happened 1 billion years ago or so, that there were two forms of microbes, you know, the prokaryotic life that formed a synergy about 1 billion years ago, and that's the archaea, and which, by the way, we didn't even recognize archaea existed until about 3 decades. It differs from bacteria in a few subtle, you know, the cell coats and other things, and that by forming a synergy, a symbiosis, they were able to increase the amount of energy by 3 orders of magnitude a cell could do. That may have not happened anyplace else, or, you know, it didn't happen for 3 billion years on Earth. So the question is that we just don't know, and there is a big argument. Well, there's an argument. I wouldn't say big because there's probably only a few hundred people involved in it. Is that should we try to signal? And this is the METI thing, and of course the Dark Forest, which was popularized by the Chinese science fiction book, The Three-Body Problem, about Alpha Centauri, by the way. Good book, bad astronomy. But you know, that Hawking, for example, we had an additional program we're going to call Breakthrough Message, and we were going to think about messaging, and Hawking was absolutely opposed to this, so we felt that it wasn't a good idea to have our senior science advisor stand up and say this is a stupid idea. I was also told by the chairman, the former chairman of the U.S. House Oversight Committee for NASA, that if I tried to do anything related to messaging, he would shut us down. You know, you don't have any government money, so I'm not sure what he would have done. But you know, on the other hand, there are people trying to privately send out messages. So I don't know. I mean, it's a really interesting question, and that you know, alien life is likely to be truly alien, and alien intelligence even more alien. So
I would a little add, because I just wrote a grant with Avi on your board there, and so on civilizational game theory. So the idea is that, so you get a lot of these remarks from Hawkins and others based on essentially the meeting of civilizations over the course of the last 2,000 years. So they'll talk about, you know, Columbus but there's actually no theory for this, and so the standard framework through which people look is something like the Prisoner's Dilemma, the one-shot games, and but when some of our faculty actually did early experiments with the ultimatum game, I don't know if most folks probably, this is a game. Will gives me $100, I get to offer you a fraction of that, you get to accept or reject it. If you accept it, you get your fraction, I get the remainder. If you reject it, we both get nothing. Okay? And so the standard sort of neoclassical optimum is I give you epsilon, I give you the lowest denomination that I possibly could, and you say yes because you're getting money for nothing. So if you assent, and you say sure. Of course you don't, right? When they do these experiments in world cultures, there are some cultures that will only accept parity, there are other cultures that want you to offer more than half. And so the standard economic intuition for what looks like the solutions to these games are not really real. And so I think our conception of what looks like a Nash solution is not necessarily generalizable. So I think we don't have intuition, I guess what I'm saying in a long-winded way, is we don't actually have good game theory to ask questions about what's a likely outcome of an advanced civilization meeting a slightly less advanced one. We just have a series of anecdotes from Earth history. Yeah.
Just wanted to add to, sorry,
Oh, I don't, you, anyone, whoever's loudest.
So it seems to me there's a kind of interesting difference in the search problems that you're dealing with. And in some ways, the nuclear one is easier because you could imagine a causal model that's generating the data. And in fact, that's exactly what you're describing, is having a sense of, here's a causal model, we know about, how housing works, and we know about what the general size of these things are. And you're doing better, you probably wouldn't do better with machine learning because machine learning isn't using causal models to generate the data. What it's just doing is saying, look, here's the statistics on a bunch of pixels. And you wouldn't be able to get your kind of anomaly detection if all we were doing was trying to look at higher order statistical properties of the pixels. But you do have some sense of what the causal model is that could generate these kinds of data versus other kinds of causal models. So what you're really doing is trying to go back and solve the search problem about what's the hypothesis, what's the underlying thing that could be generated in this picture. Whereas in the extraterrestrial life case, and I think in the entrepreneurial case as well, it's not nearly as clear what the causal model is that would actually be generating the data. So you have one data point, which is, does this thing succeed or does this not succeed? And you don't have any kind of good causal model about what the relationship is between all these factors, including completely stochastic factors, that will end up giving you that outcome. And in a way, you're in a better, you don't have to worry a lot about, well, what is there just this completely random set of things that are coming together to give me something that looks a lot like a nuclear facility. I suppose there might be some cases where that's true, but that's not kind of going to be the standard. Your standard assumption is not going to be that this is being generated by something random, whereas it seems like in the entrepreneurial case, that often is going to be an assumption. That was part of your point about luck. So it does seem to me like there's a different structure, even though these all look like hard search tasks, there's a different structure to the task that might lead you to try and solve them in different ways.
There's an added twist for the nuclear thing, which is that you don't have access to the false negatives.
Yeah, I was going to say there are actually quite a few false positives because, I mean, all buildings look the same. I mean, I can talk myself into signatures, but there are just times when, I mean, kind of, because I have weird hobbies, sometimes we'll just sit and we'll just go pick out facilities, which is partly to learn what looks normal. And all the time we will say, well, oh, that one looks good, and then it's a hospital. Because the North Koreans have a hospital with a secure area probably for Kim Jong-un, which was a really interesting find, looked a lot like a nuclear facility, was a hospital. So, I don't know, but then also the not having the false negatives, I mean, it is really tough because you find out that a thing you thought was one thing wasn't. And so you
But the point is you've got a relationship.
Yeah,
that's
okay.
going to be true, but you have a relationship between here's the thing and here's the evidence that the thing is generating. And then, of course, there's going to be all these questions about that you always have if you're trying to do some kind of Bayesian inference about, well, is this thing really the thing that was generating that data? But that's a different problem.
Yeah, okay.
Not knowing what the thing is, not knowing what the structure is that is generating the data in the first place, right?
It's not an either or thing, is it? The search, I mean, you could do some machine learning, some computer vision kind of algorithm, and then always follow up with human beings looking at the false positives.
Right.
False negative, you're going to miss anyway.
Yeah.
Right.
I mean, it's what we try to do. It's just that the challenge is we have yet to find a machine learning partner that meaningfully reduces our search task. Because, I sometimes show my students pictures of a pair of reactors, and to me the reactors bear some similarity. And my students really struggle to see the similarity. And I really go back and forth at an analytic level. What is it about my training that has talked me into seeing these things? And am I seeing something that's not actually there? So, but you're right. I mean, the way you describe it is exactly how we want to do it. Is we try to generate signatures, we try to teach machines to look for them, and then we try to come back and provide that like artisanal touch, but it's been pretty disappointing.
You could do an alien building a nuclear
We only have time for one last question, and then we should probably wrap this up. I know I cut you off a minute ago, Syed. So do you want to ask
I did want
a closing question?
Do you mind if I
Please,
wanted
sorry,
to just
apologies.
add, I think you're right about the causality. I think that one of the problems that we see in the investing world is that you tend to overinterpret causality. And so you have an investor who, because for an investor, you make a decision and then you see the outcome many years later. And so unless you took extremely copious notes about every single company that you saw, which most investors don't, then by the time you get to that outcome, now you're going back and thinking, oh, well, of course that company was going to do great because, the founder wore a hoodie, or the founder went to Stanford, or, because this was their third company and their previous two had been good. And you can test some of those things, but it's really hard for people to go back and understand why that particular decision was successful. And then they, of course, also don't analyze, most of the time, they don't analyze the ones that weren't successful. They don't apply the same level of scrutiny to that. So it's really hard to tease out those factors.
Thank you. My question was for you, Peter, was a follow-on to the intelligence one. Ernst Mayr and Carl Sagan debated famously, and Mayer's point of view is that intelligence is perhaps the lethal mutation. And when you look at the example that we have, you look at them now, the ones who are extremely intelligent sort of don't survive that long, and the ones that do are like bacteria that can adapt themselves, or like the ones who've locked in a fixed ecological niche like beetles or something. So are we looking for intelligence that exists right now, or are we looking for intelligent civilizations that might have existed at some point in time?
Well, that's a very good question. There's if we're looking for intelligence, you're looking for right now it's all looking for techno-signatures. But one of the other things is look for artifacts of something that might have existed a long time ago. Do we see evidence for alien mega engineering? So you try to look for a weird star that shows something anomalous, and we found a few. One of them a few years ago was in the Kepler database to look for exoplanets. We were looking for shadows of planets going from the star, and there was this one thing that had a lot of really strange shadows, and so we ignored it. But then a postdoc at Yale, Tavi Boyarzin, was working with some students, and they said, this is really weird. And so it became called Tabby Star. And the first explanation is there was a decaying alien megastructure around it. And we finally proven that there was simpler explanations. But I think this is the really interesting question is life, intelligent life may have existed. But more fundamentally, is there any life? And one of the big focuses in their life other places in our solar system, and did it come from elsewhere? And is it all the same? And there's a lot of focus on Mars. It's a very open question. There's focus on some of the moons in the outer solar system, Europa and Jupiter and Enceladus and Saturn. My favorite place to look is the upper atmosphere of Venus, which is there's reasons for that. There's good reasons that there could be life there. But I think that knowing nothing right now, it's a statistic of one. You just look for anything. And it's, whether it's a techno-signature or whether it's, one of the other things to look for is if we find planets orbiting these nearest star systems, within a decade we'll be able to look at the atmospheric chemistry. And from that, at least we assume we can figure out that our atmosphere has been modified by life for 3.5 billion years. If we find, a non-equilibrium gas, presumably oxygen, but it could be methane or something else. If we find water, we say, okay, that's evidence. So it's a very open question. This is fun, but it's, and I think new thoughts and what we should look for are interesting. And so one of the things we're trying to do is ignite, scientific and public interest globally.
Thank you very much.
Thank you.